Hello everyone, welcome to DMG chemistry classes, and today I am going to discuss heat capacity. And I have given you an idea about heat capacity when we were discussing extensive and intensive properties in one of my videos. So the heat capacity is the amount of heat required to raise the temperature of a system through 1 degree Celsius. And let us suppose that the heat supplied to the system is equal to Q. Okay, and the temperature of the system increases from T1 to T degree Celsius. So T1 is the initial temperature and T2 is the final temperature. So the rise in temperature will be equal to T2 minus T1, and T2 minus T1 I have represented it by delta T degree Celsius. So delta T degree Celsius is the rise in temperature. Okay. Now to increase the temperature by delta T degree Celsius, heat required is equal to Q. So to increase the temperature by 1 degree Celsius, heat required will be equal to Q upon delta T. And as I said earlier, that heat required to raise the temperature of the system through 1 degree Celsius is called as heat capacity. So this Q upon delta T will be called as heat capacity, and it is denoted by the symbol C. So C will be equal to Q upon delta T. And what will be its units? Its units will be joule per Kelvin or joule per degree Celsius, even calorie per Kelvin or calorie per degree Celsius, depending upon the units of heat and the temperature. Further, the value of this delta T is finite value. The values of both temperature, rise in temperature and heat, they are having finite values or they are large values. And if I want to write this expression for very small increase in temperature, then this expression will be written as C, it is equal to delta Q upon dt. This means that if the temperature is increased by a very small value, that is dt degree Celsius, and the heat absorbed to increase the temperature by dt degree Celsius is equal to delta Q, then the heat required to increase the temperature by 1 degree Celsius will be equal to delta Q upon dt. Okay, so this is also an expression for what? Heat capacity. So heat capacity can be represented is given by two equations. Number one, C is equal to Q upon delta T, and C is equal to delta Q upon dt. Okay, and we know that heat is a path function. Heat is not a state function. So if heat is a path function, then certainly heat capacity would be a path function. Okay, then to know its value, the conditions like constant pressure, constant volume has to be specified, because these conditions defines the path. How? Let us explain it. Suppose I have a gas enclosed inside a cylinder fitted with the weightless frictionless piston. Okay, and here we have gas. Okay, so now I want to increase the temperature of this system, this gas, through 1 degree Celsius, and I will have to supply heat. And let Q1 is the amount of heat supplied to the gas, and its temperature is increased by 1 degree Celsius. Okay, then during this process I will keep the volume constant. Okay, that is, when the heat will be absorbed and temperature will increase through 1 degree Celsius, the volume of the gas will be kept constant. The gas won't be allowed to expand. Understanding? So here the path is that this process is being carried out at constant volume, and the heat absorbed is called as heat capacity at constant volume, and it is represented by symbol Cv. So this is heat capacity at constant volume. Further, if I keep the external pressure constant, if the external pressure is kept constant and again the heat Q2 is supplied to the system and temperature of the system or the temperature of the gas increases by 1 degree Celsius, then this Q2 will be called as heat capacity at constant pressure, because during this process pressure is kept constant and it is represented by the symbol Cp. So heat capacity is of two types. Number one, the heat capacity at constant volume and heat capacity at constant pressure. And these conditions of constant temperature and constant volume are very important. And I will explain these conditions in detail when I will be discussing that Cp is greater than Cv in my upcoming video. Okay, so please keep watching my videos. Also like and share my videos and subscribe my channel. Thank you very much.